So this video will be an introduction into sampling distributions. It's going to look at vocabulary in terms of parameters versus statistics, and this really should just be a review of something we did earlier in the year. It'll talk about what a sampling distribution is, and I'll show you some models on an applet, and then we'll do a quick discussion on accuracy versus precision and why they are both necessary. Right, so we're using all of this in terms of inference. And really, inference is putting all of statistics together, right? The idea of gathering data, making graphs, finding probability. And what inference, this concept is, it's the idea that we can estimate a population by just using a sample, right? It's very hard to actually gather an entire data from a population. And if we do it well and take a proper sample, we can actually use just a sample to represent a population. Right, so here is our big, large population. And if we randomly sample and do it well, right, that sample should be a nice subset of that larger population. In terms of the vocabulary, right, a parameter, that's what we're going to call something that describes a population. Mu or sigma, right, those are values that are parameters and they describe populations. Parameter P, population P. Whereas a statistic like X bar or S, that's a number that describes a sample. All right, so here's an example. A business owner wants to know the average household income in her business's zip code. Right, she's going to randomly take a sample of 80 households because she really can't gather the data from every single business. And she wants to find the incomes, and when she does take that sample, it comes out to be those 80 households is about 46,000. Right, so what do all our words, population, parameter, sample, and statistic mean in this specific example? Right, our population, that represents all of the households in the zip code. Our parameter will be mu, our mean income of all households in the zip code, and that's what we want to find. But we're going to find it by gathering a sample. Our sample is the 80 surveyed households, right? Our sample size, our N is 80. And finally, from that sample, we will get a statistic, right? That's our X bar, and that's what we're hopefully going to use to measure the population. So what is this sampling distribution that I've been talking about? Well, let me show you an applet to kind of help describe what it is. Let me change this to skewed. So let's say here's a population that kind of represents our incomes, right? Household incomes really, that's a data set that is skewed to the right with not many people earning the big bucks there. Okay. And here is our entire population. I'm going to take a sample, let's say, of size 10. So I'm going to sample just 10 households. So notice on our population, the blue here, that's our population mean, and the pink is our median, right? And obviously, the mean is pulled towards the skewness. So here I'm going to take a sample, right? So here's my 10 households. Boop, 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 boop. Right? And they kind of are all over the place. When I average them, right, the blue down here is the average, right? That's a statistic. That's an average value of my one sample that I took, right? So this represents individual data. It represents the entire population. This sample of 10 represents individual data, right? You remember you saw them falling down. This down here in blue is a statistic. It's the mean of a sample. Our average of our sample, well, it's a little on the low side, right? It didn't quite come up with the mean of our population. But that's what happens when you take a sample. So you know what? Let's take another sample. So here we go. Here comes 10 more households. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So this mean was a little bit higher. This one actually is a little bit closer to the true population mean. And again, remember, individual data, this is a statistic, right? This measures means, right? And our goal then is to start to take all the possible samples that we can, right? Let's do one more sample. Here comes our 10 households that we're sampling. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And I've gotten kind of 3 different answers. One that's low, one that's right about where the population mean in, and one that looks like it's a little bit above. So what do you think will happen if I take lots of samples of size 10? Right? Well, I'm going to go ahead and do that. I'm going to take 10,000 samples of size 10. Right? Boom, right? So here are my 10,000, and notice there's actually 10,003 samples of size 10. This blue down here, this is called a sampling distribution, right? Here's one sample, but this is a sampling distribution. It represents taking all possible samples of size 10 and finding their means. Again, this is individual data. This sample, right? A sample is individual data. Let me take one more, right? So here is a sample. Those are each individual data points. The blue down here, the sampling distribution, those are statistics. Those are averages again. So make sure you get that distinction between the 3. In reality, we're really going to take just one sample to represent the population. Again, this is kind of a theoretical model. But look what nice thing happens, right? Here is our population, which is very, very skewed. When you take a sampling distribution, and again, it depends on the sample size, right? We took 10 here, how big that is, and we'll talk about that at a later time. But this becomes a nice normal distribution, and you can really start to look at the spread of the data from your sampling distribution. So again, a sampling distribution is a graph of statistics, not individual data values, right? And it's a statistic that represents all possible samples of whatever size n you're taking from the population. Right, so again, remember, I think I keep saying it over and over again, right? Here's our population. It represents data. It's representing incomes. Here's our sample. It represents data. It represents the sample of incomes. And then finally down here in blue, right, that's our sampling with an ing distribution. And it represents statistics, right, the means of each of those samples that we took. And lastly, let's talk a little bit about the difference between accuracy and precision. So look at these different graphs in terms of precision and accuracy. Precision is all about variability, how much variation there is in the different estimates that you got. So notice both of these, this first one and the last one, have a lot of precision, whereas accuracy is talking about how close you are to the true value. This one has some accuracy here, and also the last one has some accuracy. Notice the first and the third one are inaccurate. They actually have a lot of bias in them, and that results from not taking a proper sample. What we're looking for in a sampling distribution, obviously, is our 2 greens. We want to have precision and we want to have accuracy. And if we apply this to our example, right, here is our same populations, but notice the left side has a sample size of 5 and the right has a sample size of 25. Right? They both are fairly accurate or unbiased, right? Their centers are kind of both along, if you follow that green line down, the same as the population. Right? So they're unbiased, they're accurate. But what you're noticing, the difference down there in red, is that the larger your sample size, the less variability, right, the less spread you're going to get, which really means you're going to be more precise. So how do you avoid bias? Right? You sample randomly. You want to get a good sample. And then how do you reduce variability? You increase the sample size. And we'll put this together and look at that test data again. and taking a sampling distribution with a larger sample size.